Hello everybody, welcome back to DWF repair videos. And today I just received these two PCBs. They are the same thing, and this is something I really was looking for a long time. These are the Asteroids, Atari Asteroids arcade PCB games. This is a number 2 revision here and the number 4 revision. These two boards were made around the copyright Atari 79. The two boards were made both in 1980 actually. This one is early 1980, probably January or something, and this one has a date of June 1980. So these two boards were sold as not working, and indeed they have been attempted. They have some previous repair attempts, some substitute chips, snapped capacitor here, but probably that could be for shipping or something, handling, I don't know. Another socket chip here, another two here. This one is quite in worse shape. This chip is has some rework around it, I don't know. And socketed chips like in a very funny way. This one, look at that, this diode where a capacitor is supposed to be, well, that would be a very long repair. I plan to only keep one board. I plan to repair both, but only keep one for me to rebuild replica cabinet, scaled down, and but repair the two boards and sell the second one after it's been repaired, to recover some costs of time, money spent on the boards, and so on. So let's first understand what we need for this repair. So we'll talk about the Asteroid game. This is a vector game actually, and we'll see what that means. Asteroids was a very popular arcade game soon after it was released. However, my intent is acquiring most of the games that left a special trace in my life. Asteroids could be the first arcade game that I ever played. I can't recall which one I played first, between Asteroids and Space Invaders. It has been a long time after all. But I don't remember exactly where I used to play Asteroids, in a little bar in my hometown. Well, I also remember that I used to play Space Invaders at a large arcade in the same period, so I can't really tell which one I played first. I liked both, but I've never got any good score on either of the two. I've been looking for an Asteroid PCB, Space Invaders PCB, but they are actually more difficult to find than Asteroids ones, and they fetch a higher price. Don't know why. So let's get started and see what we need to do. So first thing would be getting the proper connector to interface on the board, downloading the technical manual, the service manual of Atari Asteroids game, and make a suitable power supply, and have a clean on the both connectors probably, and then checking capacitors, electrolytic capacitors, with if they have an too high ESR, they will be substituted. Checking for short on the 5 volts line, checking the diodes, semiconductors, transistors can be checked without powering on, just to make sure we don't have any broken part that can be checked before trying to power on the board. Fix these obvious problems. This socket will be removed, board cleaned, installed in a proper way, checking all the connections. Also this diode doesn't belong here, I don't know. I will check the schematic, but on the other board there is simply the coupling capacitor across some power rail. So this will be probably the same thing, even if the boards are different revisions, but there are schematics available. And so there is quite a lot of things to do before actually the first power on. Okay, the capacitor inspection found two marginal capacitors. These are tantalum kind of electrolytic actually. And what I do to identify the capacitor, I have non-made ESR tester that can measure quite reliably the ESR of capacitors, tantalum or aluminum electrolytics. And this one has a very low ESR, it's below 0.5 ohms. So I can test on circuit, and when I find something suspicious, usually when the ESR goes more than 2 or 3 ohms, I remove the capacitor and I will test it with an LCR meter, an HP LCR meter, but I'm quite sure I have to change these two capacitors because the ESR went well over the 2 ohms. One is almost 5 ohms actually, and so these are C62 on this board and C24 on this one. And if we go on the schematic, actually they are both on the sound generation circuit. This is C24, which is part of the timing circuit that makes the explosion sound. It's all analog sounds generated with random noise, logic gates, and resistors, capacitors. So C24 is part of the explosion sound, and C62 is part of the ship sound. So I'm tempted to replace these with film capacitors maybe, but we'll see what I find. Probably use tantalum. Axial tantalum are not easy to find nowadays, but I will search and see if I have some suitable capacitor. Otherwise I'm quite sure I can use regular field capacitors in this kind of circuit. This is low frequency sound generation. Here too, probably this is some timing or smoothing, or something like that. So I'm pretty sure I can use a field capacitor, but I will try to find some tantalum, the right capacitance. Doesn't matter much the voltage. He has always 5 volt circuits, in this place. So in this image we can see the measure of one of the original capacitors. The instrument settings are 1 volt, 1 kHz AC test signal and 6 volt DC bias. As you can see, the capacitance value is still very well into rated tolerance. However, the dissipation factor is rather high for a 1 microfarad capacitor. The proof comes from a new 1 microfarad tantalum capacitor. With the same instrument settings, we find the dissipation factor to be 10 times less. So it is wise to substitute those capacitors, as they will probably degrade even further. So this is the board that seems to have been more abused. I'll try to remove this socket, have a good clean on the board. You see how this was mounted. I don't know why. Then also this diode, I think it should not be here, this one. So remove this one and check. Component should go in this position. Look in the schematic. And that's it for now. Then after that I will try to understand what's going on here. But first, this area will be I will deal with this one first. Look what a mess has been done. There are some broken traces, missing pads. Oh man, that's why if you don't have the proper tools, it's not going to work. I'm sorry people, if you don't have the right tools and the right skills, it's not going to work. So look here, I have basically to check all these two chips connections and make sure, after cleaning, of course, and make sure there is all the proper connection everywhere. And it's not better on the other side. I had actually to remove the two sockets, because even this one was really a very poor job. There was a socket with a missing pin, go figure. And remove that diode too. So we'll need to check every connection. Let's get a cleaning of these, check the connections. Fortunately there are vias nearby, so I can check after soldering the chip, the socket I mean, if the connection are made. Otherwise I will bridge the trace on the underside. But let's see, that first must be cleaned on both sides. Connection check it without installing sockets, then installing the sockets and check everything again. By the way, that diode was installed in place of C100, as we see in the schematic. This capacitor sits between plus 15 volts and ground, and its function is to smooth the local voltage supply of EC12. These capacitors are called bypass capacitors. If that diode was installed in the wrong way, it would cause a short on the 15 volts rail. And why it was there, I don't have the slightest idea about it. So I had a good clean on all the area, and I'm going to use this kind of sockets so I can solder from the socket from both sides. Should they hole fit through, should be broken from the previous work, so I can solder this socket on both sides of the board and make the contact between the two layers work again. And this is particularly ruined. Most of the pads are missing, but only two tracks appear to be connected on this side, so I will check after soldering that we have continuity to these two wires, and if not, install a wire. Also found a capacitor replacement where there was installed the diode. This is a similar capacitor like the other ones on the board, so it won't look too bad. And also connectors arrived for the edge connector, so I can also solder some wires and make the board bring the power supply at least. And this is well, not new, they are used, but original old connectors with very good quality. And I prefer having bought a bunch of this one for a low price because they are used, but I think they are much better than the modern Chinese connectors. These are really good connectors. And also had a clean on the edge connector with metal polish passed. And I think I will just apply some tin where the copper has been exposed, but otherwise the other connection seems very good. Okay, so I had to bridge some tracks. This one, for example, with cut IC pin, and I verified the continuity. All the tracks are making good contact on this side. Of course, after installing also the other socket, I will clean very carefully all the flux residues. Okay, also on this side seems so fine. I had to solder the pins from this side with the fine tip of the solder iron, but this connection now works to this wire, and this other works to this wire too. So yeah, I can install the original IC I found, which was replaced anyway, but I don't know if it's good or not, but for the moment it will stay there, and proceed installing this other socket and cleaning all the flux on the other side. This one looks much better, so I probably won't need to do much soldering on this side, but also I will check every connection, making notice where all the top tracks go, so I can check after installing the socket if the connections are good. And here it is after cleaning. Of course, cannot go too hard with cleaning, with the traces are really so mistreated and ruined, but well, it's good enough. Surely much better than this one. I'll work on it now. Okay, it seems no amount of work can really clean this mess, but at least I can see what has been connected and how, so I can check the schematic, and I really hope I don't have to remove this. Look, there's almost no left pad here. I don't know why, but I don't know really. It's like fixing a car by smashing it with a hammer. Would you do that? Okay, also this side doesn't seem much better. Dirty flux around. So I need to check if these two connections on the schematic appear to be needed. This is bridging two pins, this is bridging one pin to one wire here. Then I will remove this mess and install the wires on the underside, and so I can better clean this side and hope this chip is good. It seems the original chip. I don't know why it has been removed, I don't know. But another very inexplicable thing, if you remove a chip on a board like this, you must always install a good socket, good quality socket. There is no excuse for not installing a socket in this case, because you don't want to work twice on the same pads, on the same traces, because even with the right equipment, with the right skills, you're going to make some damages sooner or later if you rework the same area. These PCBs are not made for be reworked more than once maybe, so there is no excuse again to not install a socket. UC4 is the main clock divider for all the board. A large part of the pins are connected all to a pull-up resistor R29. I found a couple of these connections were missing, and also the 6 MHz trace was broken. So I had to add back the 2 wires to restore these broken traces, and I added them back to the bottom layer. So after verifying that this part of the circuit is working well, I also add a few drops of epoxy to secure these two wires to the PCB. One final issue on this board that can be addressed before even powering the board up, and this is this CPU, the 6502. If we look at the manual, we see it recommends using a 6502A, which is the 2 MHz version, because the CPU will run at 1.5 MHz, and this the non-A CPU is a 1 MHz version, so it would be way overclocked at 1.5 MHz. This may be a good CPU. I mean, it can be working very well at 1.5, this particular one, but since I have a 6502A, I will put the right processor in this board and maybe test this one on Commodore PET later. There is no reason why I take chances while repairing a board using an overclocked CPU. Just a quick check on the other board, the -041. The CPU is probably the original one. Here is a 6502A, and from Signer Tech, which is just the same spare I have, and so this probably is the original one, and it's an A, means 2 MHz version, as it should. I was not remembering correctly. The only 2 MHz 6502 I have left is this MOS Technology one from 1983, and so probably I will be looking into the 1541 drives that I have and see if there is some A version there with socketed, of course, so I can swap one of the 1 MHz parts that will work fine in a 1541 and get another 2 MHz spare. And interesting, this A has been added after the main marking of the chip, probably because they tested and it was working well at more than 2 MHz actually. So typical MOS technology, very typical. Okay, now it's time to see on the other board what we find just by inspecting the board. So here is the second board, the -4, and on this side we have seen already some socketed chips. Here's another one. Generally looks a bit better than the other one. Just failed to mention before, but also checked all the semiconductors. This transistors. There are some diodes in the board. Transistor here. This is not very essential, but must be checked, of course. And always looks fine also on the other board, but Q9 cannot be reliably tested with the transistor in circuit, because the junctions of this Q9 are in parallel with very low resistors. This is the output, the video intensity output. So this cannot be tested in circuit, but I guess it's fine. Anyway, it would be evident if something is wrong or when the board would be powered up. And so let's flip this board over and see what we find outside. Okay, the other side, it's well, almost the same bad work as before, but not too extremely bad as in the other board. So what I'll do, will clean, of course, the flux as much as possible, check the connections on the chip that has been socketed. This is quite an acceptable job here, and I won't show again the process. It's the same thing, just have a good clean on the flux, check the connections referring to the schematic, and then that's all. And I will show the routine process of this connector, which is a slightly different method that I showed on the other arcade board that I repaired. And I think it's interesting because it's quicker and very effective. Well, okay, it turns out it was actually worse than the other. Chips removed and socketed are more. Everyone has big issues like missing pads, broken traces, burnt PCB material around every pin, something here, a mess, a real mess. So I did my best, but probably I'll find issues when repairing this board. I think it was reworked with flamethrower instead of a soldering iron. That might be the reason. So the first thing, using a little bit of paper or whatever, is to use the generic metal polish solution, like the ones for copper, brass, or similar metals, and apply just a little bit on the connector and rub on all the fingers, and as you can see, a lot of oxide remains, so we'll just do a couple of passes, not much, and then we need to polish all the connector with isopropyl alcohol or another solution to eliminate all the products. Then after cleaning, we mostly have shiny contacts, but on some contacts we can see the copper getting through, so it's like a pinkish color, and that's the copper. And on the high current contacts, it's better to retin the contact, and what we do, we get a little piece of folded toilet paper, and we start applying new tin here. We take our time until we see the copper disappearing under the tin, because it takes time to get all the tin over the copper. And then with this we remove the excess tin in just single movement, and the contact is shiny and flat, so very easy. And we repeat on every high current. Well, if the contacts are mostly okay, like in this case with just a little copper shining through, I will only do the big traces contacts. There is no need to retain the signals like buttons and everything. Only the power supply contacts would be needed. Okay, so after completing the retaining, I did not do on all the contacts, just the high current ones, as I said. Our last cleaning with alcohol would remove the flux residues, which are not much anyway, because we remove the flux during when we remove the excess tin anyway. But quick cleaning with alcohol will surely help. So this first part of this repair journey ends here. On the next episodes we'll see how we'll make a power supply to power up the boards, how to why we need a vector monitor for this kind of game, what is a vector monitor, and how plan to obtain one and or make one. Probably I will make one. And on another episode we'll see the actual repair, probably, because it's so much things to explain and to show. I think there will be at least another 2 or 3 videos on this series. So hope you enjoyed. Until next time, and please leave the comments if you have questions and everything, and thank you for watching.